Hello, and welcome to the session on Workflows and Code Management with Spira and TaraVault. My name is Adam Sandman, and I'll be presenting this session today. And the objectives for this session are giving and sharing the best practices and recommendations for how you can use Spira, mainly Spira Plan and Spira Team, with TaraVault, our source code management solution, to manage your source code. And the examples will be both using Git primarily, but also Subversion as well. I'm also going to be talking about the workflows you can use for managing your development activities, writing tasks, linking the tasks to source code commits, using our IDE plugins, and also some of the actual commit workflows that are recommended specifically for Git, and as I said, also with Subversion. At the end of this session, you'll have a good idea about how you can use Spira and TaraVault to manage code, manage source code repositories, and use CI tools like Jenkins. So first of all, let's talk a little bit about the integration options that we provide with Spira. First of all, if you are on our cloud platform, then by default, you will have the option of using TaraVault. TaraVault is a completely integrated, secure cloud system for Git and Subversion repositories. Most of our clients will use Git for distributed version control. We do have some clients that will use Subversion if they're dealing with very large files and want or prefer a more centralized version control workflow. You can use TaraVault with both Git and Subversion, and different projects can use the different tools. So some projects can use Subversion, and some projects can use Git. It's really up to you. If you're using our on-premise solution, then you will integrate with a variety of different source code tools that you would host yourself. For example, Git, Subversion, Helix, Visual SourceSafe, for those who've been around for a while, TFS, Mercurial, and CVS. You can actually use our hosted platform also with third-party solutions as well, as long as they're internet accessible. You can disable TaraVault and connect it to a third-party platform. That's quite common if you're using something like GitHub, GitLab, or Bitbucket to do your code management already. In addition to managing the code itself, you can also integrate Spira with the different development tools where you write your code. And for example, we have integration with all the tools listed here, which is basically the entire family of IntelliJ tools. For Microsoft and .NET and other Microsoft technologies, we integrate with both Visual Studio, various versions, and also Visual Studio Code. VS Code, as it's often called, is used a lot with scripting languages and TypeScript and JavaScript and things that don't necessarily need a compiler. Visual Studio is used primarily for .NET, C++, and other Microsoft technologies. Of course, if you're building mobile, you'll be using Android Studio for anything using Android, and that's actually a flavor of IntelliJ, so we also support that as well. And then lastly, for those who are still using Eclipse for Java, we do support Eclipse as well using its Mylin extension. Right, so that's what we support. Now, how do you use it? So let's talk a little bit about the source code integration first. So within Spira, you can browse source code repositories. Here's an example right here. You have your folders on the top left, and you have the revisions then underneath, and you can see all the files, and you can browse the repository as you wish. You can also change the branch you're viewing. I'm looking at a master branch right now. And so you can look at any branch, any set of files, and browse it directly in Spira. And that's regardless of what technology you're using. It could be Git, could be Subversion, or it could be some of those other tools that I mentioned as well. You can view all the different branches right here, and depending on the methodology and the tool, this is an example using Git Flow, which we'll talk about later. So this is an example using Git. We have different branches, feature branches, release branches, and so on, and you can see them all within Spira. Once you have a file committed, you can click on it within Spira, and you can see a preview of the code. This is showing you the latest revision in that current branch for that file. You can also choose a specific previous revision and see the code, that file of the code for that revision as well. And we do have syntax highlighting right there for most file types. So that way, not only do you see the code in its textual form, but you can also see the syntax highlighting. So the classes and the import statements are a different color than the strings and the keywords. And we support most languages in terms of syntax highlighting. This one example here is Python. Once you've got the file viewed, you also want to see all the changes that are made. When you click on the revisions tab of a particular file, it's going to show you all the changes that were made to that file, and you can sort by the revision ID, who made the change, when it was changed, what was changed, and also the summary, which is the text that the person put in. Typically, the most common things will be defined by the most recent date, or it might be by a specific person. The revision format depends on the tool. This looks like Subversion here with the revision numbers. If it's Git, it's going to be a alphanumeric GUID or graphic global universal ID, a hash. Those tend to be less meaningful, but whatever you have, it will be displayed here from whatever tool you're using. Of course, a big part of using Spira is not just to see the source code, but it's to have traceability. And so you can have traceability from each of the revisions to the code that is in that revision. And of course, you can also have the traceability from that revision to all of the artifacts that necessitated the change in the first place. So for example, I've got a requirement where a user story and the developer is implementing that feature. They want to commit the code against that requirement. And they use that special square bracket token you see here. And if you're on the requirements page, you can click on it and it makes it into the clipboard. If you're using our IDE extensions, which I'll show you, it automatically puts that into the clipboard for you and actually can be automatically in the commit message, which is nice. We also have an extension as well for Tortoise as well. If you're using Tortoise SVN or Tortoise Git, we automatically will have the ability to select the revisions if you want and put those in. The important thing is, though, that traceability between that token and that revision means that I can look at any given revision and see why did we make this change to the file and the code. You can see here I fixed some bugs, which are the two in red. I also implemented this feature. And we typically are going to use it with bugs that we fixed, user stories or requirements that we implemented, or tasks that we completed. Those are the three most common things. You can link it to any other artifact in Spira as well, like a risk or a test case if you want to. But the most typical three will be tasks, incidents, and requirements. You can do the addition of the association directly in the source code management tool just by simply putting in that special token, the IN number in square brackets or the RQ number. If you forget, don't worry, you can always add an association inside of Spira using the button, and that's stored in Spira natively, like that. You choose the artifact type, the ID, and the comment, and that gets added to the association list. So that way you can have traceability from revisions to artifacts in Spira. Now you can also link files as well. So they become attachments. So if you want to see a particular source code file and link that, there's also an option to add it as an attachment link. So you can either link the individual revision, so what changed in this version, or you can link this particular source code file with a particular artifact. So we have two kinds of associations you can do. Then if you go to, in this case, the requirement, you can see the reverse, which is not just this, which is previously we saw, this is my revision. These are all the things that the revision touched. This is now the opposite view. I'm on the requirement. This is the ability to edit books in the system. It's one of our samples. You can see here all the changes that were made to implement that feature. So we've got two different code revisions, and you can see what source code changes were made to implement this one feature. So we have it in both directions, from the artifact in Spira to the revisions, and then from the revisions back to the artifact in Spira. So it's an end-to-end relationship. Now, that's some of the linking that you can do within Spira. We'll come back to that when we talk about the visibility in the CI pipeline, but that's how you would link code to the requirement or the task or the defect. So now, managing the source code itself. There's different workflows you can follow. If you're using Subversion, it's actually pretty simple. There's only really one way you can do it. So in Subversion, if you're familiar with the tool, you typically have a trunk, which is the root of the work being done. And then you have another set of folders that you have called the branch folders and the tag folders. And the idea is that all new development work is done in trunk. That's the current main line of development. When you finish that line, you release it into production. What you'll do is you then commit that into trunk, but then you make a copy, you make a branch into a new branch that you call a tag. So if you have a release that goes live, you would then create a new tag called version 1 or version 2 or version 2.1 as you see in this diagram. That's the tags for milestones and releases. Those are not changeable. On the other hand, you might decide that we're going to release version 3 now. We're going to work on version 3, sorry, but you're also going to continue some maintenance work on version 2. So what you'll do is, as well as making the tag, which is the release that's been released and set in stone, you'll also create a new branch, which is a numbered branch, under the branches folder. And basically, you maintain old versions there. So that way, if I'm going to make a fix on the current version, version 3, I'll do that in trunk. But if I need to make the same fix or just a general fix for an existing customer on one of the existing versions, I will do that on one of the branches. So the concept is you do new development work on trunk, You do old development work on old releases in branches, and you maintain a read-only copy effectively of what was released at a specific point in time in tags. So we've talked a lot about branching. What about merging? You can merge changes. If I make a change into, say, version 1 or version 2 branches in trunk, what people have found with Subversion is doing the merging is not very intuitive, it's not very reliable, and generally speaking, we don't recommend it. So usually, if you're going to fix something in 2 different versions, you would fix it separately in trunk and fix it separately in branches. So generally speaking, with Subversion, you can do branching, but not merging so much. So we would recommend if you need to do a lot of merging, you should try something more modern like Git. But if you have a very simple project and the team doesn't want to have to worry about the complexity of a distributed system like Git, and doesn't need lots of branching and merging, Subversion can be a useful option. Subversion also has the advantage of being able to handle large files more efficiently, at least in our experience, than Git does. One thing to note with Subversion is in reality, branches, tags, and trunk are actually just folders. And so in reality, on the file system that you have on your local working folder, you're going to see these folders actually as folders. It's not really it's not natively handled in the same way that it is with Git that we'll show you. The nice thing with Subversion though is you can see all the branches all on your machine at once. So if you want to look at code on one branch, another branch, you can have them open at the same time. Now Git's different. Git is more sophisticated, but also with great power comes great responsibility. And anyone who's used Git and had merge conflicts or had disconnected heads or any of these crazy things that can happen with Git. Basically, Subversion is really hard to screw up. So if you're using Subversion with your team and they're happy, before you move to Git, do decide if it makes sense. You'll get a lot of advantages in managing different branches at once, but you will get a training burden you're going to have to take on. So the way Git works is it's a distributed system. So there's what's called the remotes or the origins. Those are the copies of your source code system that's on a remote server. In our case, that will be TaraVault. That's the reference repository or the remote. Every single person who works on that project is going to have a complete copy of that entire repository, not just the files that were checked out, but the whole repository, all the versions, all the branches, an entire local copy. And that's called the local repository or local repo. So the other thing they have is also what's called the working directory in the staging area. So in Git, when you have some files, so let's say you've got a remote repository, you pull that repository, that's called a pull or a fetch, onto the local repository. Now I've got a copy of the entire source code system on my machine. I then check out a specific branch into my working directory. So I can see all the files on the file system that I'm going to work on. When I make changes to those files or add new files, those changes get put into what's called the staging area. That's an area where I can decide which changes to include in my commit. So I could commit these files, and the other files that I may have changed don't have to necessarily be committed. So then once you commit those changes, they get committed to your local repository. And this is the big difference between Git and Subversion. With Git, when you do a commit, you're only committing it from your working directory and the files that you're working on into your local repository. Before it gets updated to the centralized repository, the remote, you have to do a push. And if someone else has made changes, it's at that point you might get a conflict and you have to resolve. Now, Git is a far more sophisticated beast than Subversion, and there are different ways you can work. And one of the things that we recommend is pick a methodology, communicate it, and make sure everyone's following it. It's very easy for people to get confused, work in the wrong branch, try and merge one branch into another branch, and get confused and get lots of conflicts. What we found in our experience was using something like Git Flow is the best. Now, Git Flow is a simplified way of using Git, and it forces certain conventions on you. It's actually not a separate tool. It's just a convention. But some of the source code management tools that use Git, for example, Git Kraken and Fork that we use a lot, they have Git Flow built in. What that means is the tools will actually enforce the rules for you. So if you choose Git Flow as your methodology, you will have, in many cases, tools that will force your users to follow the recommended way and not necessarily merge the wrong branch in for you, work in the wrong branch. It mitigates a lot of those cases that can happen with Git. And we found that when we adopted Git Flow as a company, we went from having lots of merge conflicts and lots of people doing the wrong thing to for the most part, almost no issues. And so it really streamlined our development. There are other approaches out there like GitHub Flow, GitLab Flow, OneFlow. You can do those as well. We're not going to cover those today. We're only going to cover Git Flow because we recommend it. Another possibility is you can do what's called trunk-based development. That means you're going to work in the same methodology as Subversion. And that means all the new work is done in the main branch, which is often called master or main, not called trunk like Subversion. So you do all the new work in master or main, And then you basically create other branches when you move on to the next, to store the old version, and you keep all new development in master or main. We don't recommend that. Some teams will do it, but really it's okay for a small team with a small number of developers. But once you get beyond that, it gets unmanageable. So our recommendation as much as possible is save yourself the anxiety, use Git Flow, and be done with it. So how does Git Flow work? Well, Git Flow basically forces some conventions on you, because in Git itself, you can name a branch anything you like. You can create a branch. Master is generally the production version. It's the version that's out there, the reference version. Git has some rules around master. You can't do certain things to master. So that's the only special branch. Apart from that, you can name any branch you want in Git. You can merge them in any order. You can merge from one branch into another branch, into master, from master. It's complete anarchy. So Git Flow provides some order. What Git Flow does, it says, okay, master is the version that's out in production. You never do any development work at all in master. There's no changes made in master. No revisions, no commits are ever made into master. Develop is the pre-production code the team is working on in an integrated fashion. It's the combined next version we're all working on. And typically you don't or shouldn't make many or any changes into develop either. Now, you can sometimes do fixing things in develop if someone's merged something and there's a problem afterwards because you've merged things together. We found in our experience, sometimes it's okay to make small minor changes, but anything that's actually a feature or is an incident being fixed, all that should be done in a separate branch of its own. And those two branches come in flavors. There's what's called feature branches, which begin feature / something, and hotfix branches, which are hotfix / something. And it's not just a naming convention, they do work differently. So what will happen is a feature branch is, okay, we're working on the next version, we're adding a new feature. So you create a branch called feature / new login page. That comes off of the current development work branch, which is called develop. You work on that feature branch, and when you finish the login page, you do finish feature, and it automatically merges it back into develop. All the features for that release get merged into develop, and when you go live, and only when you go live and ready to go live, that's when you do one single merge from develop into master to say that all that development work is done, it's now into production, which is over here. However, you release that into production, but then you find out there's a bug in the system. It's an urgent bug. The team's already started developing the next version, so you need to basically make a hotfix that's going to both be on the version that's live for these customers that need it now, but it's also going to be included in the next development work so you don't regress the functionality. So that's when you'll start a hotfix. Hotfixes branch typically off of master, not develop, because they have to be based on the current version, but the final change is merged automatically into both master for existing versions that are live and into develop. So when the new version comes out, there's no inadvertent regression of functionality. So it gets rid of the problem where you fixed it in the current version, but you forgot to fix it in the new version. That can't happen. So Git Flow is really good. It really forces us a flow. So really what it is master is the live. Let's start some work. We'll start work and develop. We'll work and develop together. We'll create branches for features. We'll merge the features into develop. Once the testing is done and we're ready to release, we merge it to master and go live. And anything we find that's urgent, we make a hotfix off of master and then merge it into, once the change fix is done, we merge that fix back into both master and develop. So all developments then develop. Master is just a reference set of releases that are live. And that's it. You can still create like tag releases as well if you want to keep like version 1, version 2, version 3 as references. So that's Git Flow. Now, this is how it looks. If you're going to actually do it within Spira and Git, this is an example of how it will look in practice. So what we'll do is, following our Git Flow methodology, we're going to focus on a feature branch rather than a hotfix. So we've got the team working. We're going to work on a new feature we're going to call version 6.x cool functionality. So this is using a tool, GitKraken. Many other tools will have the same user interface. And if you're using Git Flow for that tool, it will force you to put in the branch name feature / whatever the name is. So that's the latest development branch. Okay, we start the feature. And that's going to match the branches that we'll see in Spira once we have created the branch and pushed it. So you create the branch. Once you push it, Spira is going to pick it up from TaraVault, and you'll see it within Spira natively. And we'll show the same / convention in Spira. Okay, so now we've started the branch. We're going to write user stories. Now, sometimes you can have one branch per user story. So there's a philosophy that says every user story can have its own branch. That can be good sometimes, but sometimes you're going to have 2 or 3 user stories or requirements that really they tie together so closely, there's dependencies, that it makes sense to just have one branch for all of them. So maybe it's maybe it's an epic that's linked. So it's really up to you. The branch could be an epic wide, it could be a story wide, it could be a series of requirements. That's up to you. So we'll write our user stories in Spira. Well, in this case, we've already got a test case linked to it as well, which you can see here, which is good. If it's a complex user story, you might break it down into individual tasks. If it's a very simple story, maybe it's just a requirement. In this case, we've broken this one requirement down into 6 or 7 in this case, different tasks. We should always now create test cases in Spira, manual test cases and automated test cases. If they're automated, they might be like NUnit or JUnit, in which case they'll also be in Git. If they're manual test cases, you should write them at this point as well. Include some screenshots. They take the user story and basically describe how you're going to test it. If you go back to the idea of Agile, with every user story, there should always be an acceptance test. Because if you can't test something, how can you verify it works? And the test can be written over time. So when you first write the user story, the test, and we haven't coded anything yet, test, first development, the test might be just describing how we think it's going to work. And as we code the activity, code the feature, we'll go back to the user story, we'll make changes to refine the user story. We also should be refining the test case at the same time. Okay, now we're going to write code. So in our IDE, we write our code. And to make this even easier, we have these plugins for the different IDEs. What this means is that inside every one of the IDEs we support, you will see the tasks and requirements that are assigned to you. So that way you'll see exactly what you have to do, the name, description, all the fields for that particular requirement or task. And when you commit the code, you will actually be able to use that to click on this and it will automatically insert the appropriate token into your commit. So we write our code in whatever language and tool we're using. We also will use our unit tests, which I recommend, and you use the appropriate unit test plugin that we have for that language. So that way, when the code is compiled and runs, you can have test coverage automatically in Spira. We have plugins for all these different unit testing frameworks that you can see here. Things for .NET, for Java, for JavaScript, for Python, for Ruby, for Perl. And we have different plugins for some of them. So for Python, we've got both PyTest and PyUnit. For JavaScript, we have Mocha, Jasmine, Unit.js, and Jest. For Java, we have Test in G and JUnit. For .NET, we have NUnit and Visual Studio MS Test. So again, pick your favorite, whichever ones you like. If there's one you don't see, let us know. We can always add it to our list. And once you've written the code for the feature, you've written the test code, you commit it to your local repo, and you should then push it. And the way that Git works, I should mention, is that unlike Subversion or other tools, when you push the code to the remote repository, you're still only pushing it to your branch. So the danger was with Subversion used to be, well, if I commit my code, it's going to cause the tool to build on Jenkins, and maybe I'm not ready for that yet. But if I don't commit my code and I drop my laptop, I lose all my work. So there was always that tension between, do I commit the feature that's not yet ready, but it could break the build, or do I not commit it and break my laptop and worry about it? Well, with Git, it's great because you're still going to commit this requirement into your feature branch, and you typically don't automatically build feature branches, so it doesn't break the build. Or certainly you can have your own branch you're working in which doesn't break the build for everyone else. But it's still stored in the remote repository, so you get the benefit of a backup and a disaster recovery of your code, but you also don't worry about breaking the build. That's why Git's really good for that. Okay, so we've committed our code, we've tagged it with the requirement using either the IDE plugin that makes it automatically, or we've just manually typed it in, or if you're using Tortoise, there's an option within Tortoise to do the same thing. And now we're going to merge the code. So we're going to take our feature branch that was feature cool functionality, and we're going to merge it back into the develop branch. So we're going to take this branch we started in Spira and Git, and we merge it into develop. Now it's in develop, we now use a tool like Jenkins to build. So for example, here we're building Spira Team Develop. It's our internal Jenkins we use for Spira Team. So we have a Jenkins server that builds develop. We have a separate Jenkins server that builds master. And then we have a series of other Jenkins servers that can be configured to build other feature branches. So that way, if someone wants to be able to have a preview, like our manual tester can have an exploratory look at some of the new feature branches, they don't have to wait for it to be merged into develop. We have other Jenkins servers, but we don't consider the build broken unless you break it in develop. So it's okay to break a feature branch, CI. We just don't want you breaking develop or breaking master. And in our company, the rule is that before you can merge in our checklist, before you can merge into develop, you have to have the feature branch passing on another Jenkins machine so that the feature branch itself has to run, compile, and all of the unit tests and API tests have to go green. Once that happens, then we'll let you merge into develop. And then when all the feature branches are merged into develop, and again, the unit tests go green for all the branches merged in, that's when we can merge into master. That's our flow. So we're using Jenkins plus Git plus Spira and the unit test frameworks to determine when we can do that. So so in this case, we've built our feature branches, we've merged into develop. Develop has succeeded, it's passed, it's build number 786, it's green, we're good to go. And now we can let our testers do the manual testing on the develop branch. So the exploratory manual testers will now look at what's building on develop. They may have had a preview on the feature branch itself, but still, because you've merged in other code from other parts of the system, it could have well have broken something. Nothing that happened in that feature branch is considered authoritative. We still require our manual testers to do a full retest in the develop branch. And then Spira gives you all that functionality for manual testing. And if you want to learn more about that, there's plenty of sessions on the testing side in the workshops. And we can then track the progress. So within Spira, we'll track the progress of that particular requirement. We'll track that all the tasks are done. We can track that all the tests are done. We'll track that the code is committed. But the new thing we can do, which is relatively new this year, is you can now track for every given requirement. Not only can you track which revisions were implemented on it, we can now see where it's built. So in this example, this is the example from our live system. We actually have built this particular feature. It was adding the portfolio recent builds widget into Spira Plan. And we built it first on the dynamic branch machine. That's the Jenkins machine that's building a feature branch. And so it ran on the feature branch. It actually it ran first on the feature branch and succeeded. And then it failed, I think, when we merged into develop because of something. And then we can pass it on develop. And then once it was passed on develop, it's then merged into master, and then it builds on master. And so that way you can see exactly which branches have built this feature existed in. And you can also see, very importantly, which Jenkins machine built it, and has it graduated yet from building on a feature branch, then passing, to building on the develop branch and passing, to building on the master branch. So we know, is this feature still waiting on the feature server, hasn't yet been integrated? Has this feature been integrated, but it's still awaiting final testing? Or has this feature gone live in master and it's already out there? So we're going to give you visibility into our tool chain for every single user story, every single requirement, every single task, every single defect. You can now see exactly where it's built and what happened. And these are links. If you click on them, they take you into the build details where you can see exactly what happened on that build. So just to wrap up today's session, Spira has lots and lots of plugins that we've sort of talked about. The key ones, though, from a development standpoint would be we have plugins for all of the unit test frameworks, and you should be using those for all of your unit tests, any API tests that are in code, and if you're doing things like Selenium, even those should be using them as well. So that way you can track all the tests systematically and tie those back to your requirements and user stories. Define a code and task workflow that works for you and your team. We particularly at Inflectra like using Git now with Git Flow. We find that Git with Git Flow gives you a good, repeatable process that's reliable and mitigates some of the havoc we found in the early days of using Git, especially for people who are used to Subversion. Make sure your workflow is aligned correctly. If you're going to use Git Flow, make sure you have at least a Jenkins server for your develop branch and a Jenkins server for your master branch. You probably should also have at least one, if not more, Jenkins or equivalent servers available for building feature branches before they go into develop. Because otherwise, it's very hard for people who are not the developer to see the functionality. And in that way, it gives your testers an early look at the functionality. And then make sure the testing is fully integrated into that workflow. And finally, do make sure you're using all of the features that we have in TaraVault and in Spira for managing source code, for linking revisions and linking artifacts, and being able to use the plugins for Git, the plugins for Tortoise, the plugins for the IDEs. So that way you can make sure that when developers are committing code, they are appropriately tagging every revision with the requirement, the task, or the defect that's being impacted. Traceability is only as good as the data that's put in. Thank you so much. If you have your questions, please write them in the chat window for this session.